Alright, in this lesson we're going to be taking everything that we've learned so far about exponential and logarithmic equations and functions and using them to solve exponential and logarithmic equations. So that is our learning target for today, is I can solve exponential and logarithmic equations by using the properties of logs, which we learned in the last lesson, and converting between the two forms. Okay, so here I want you to go ahead and evaluate each logarithm. You can do it in either way that you feel comfortable doing that. So I'm looking at my exponential equations in this form. B, my base, to the cx equals a, where the exponent includes a variable. That's my exponential equation. Okay, if m and n are positive and m equals n, then log of m equals log of n. So I know that I can turn them both into logs, and we'll see this in our example here. So therefore I can solve an exponential equation. So I'm given this equation, 7 to the 3x equals 20. So first thing I want to do is I want to take the log of each side, and I use the common log, right, which is log base 10, because that is something I can use in my calculator. And we will end up using that, so we want to use the common log. So really I have log of 7 to the 3x equals log of 20. I use my power property, right, because I've got this exponent and I don't want an exponent right here, so I pull that down out front. So I have 3x log of 7 equals log of 20. And remember, I'm trying to solve for x, so I want to get x all by itself. So I know that I'm multiplying a couple of things times x, so I go ahead and I divide both sides by what I'm multiplying by. So I'm dividing by that 3, and I divide by the log of 7. So I end up with log of 20 divided by 3 log of 7. This is something I can go ahead and just put in my calculator, right? Because they're all just numbers and values. So I go ahead and I use my calculator, and I solve, and it's approximately 0.5132. And so then I can go ahead and put this back in, this number back in for my x, and actually use my calculator and solve it and double check my answer. Okay, so the big thing here is when my exponent has the variable and I'm setting it equal to something else, I go ahead and I take the log of both sides because that is the easiest way to solve these equations. Okay, so here's a couple of examples that I want you to try on your own. Using this same way that we did it, take the log of each side and then simplify and get x by itself. So go ahead and work on these problems for me. So another thing we're going to be using is called the change of base formula, because oftentimes we're not given the common log, so we can use our calculator, but we really need to be able to calculate those answers. So here's my change of base formula. So I've got log base b of m. So what I can do is I go ahead and in my calculator, I go ahead and I use the common log, because that's what the calculator is, right? So I usually want to use 10. So log of m, so the number here divided by the log of what my base is. And this is my change of base formula, and we're going to be using this a lot here. Okay, so here's an example using that change of base formula. So we're going to use the change of base formula to evaluate log base 3 of 15, and then convert it to a log in base 2. So the first thing I'm going to do is use my change of base formula, right? So log base 3 of 15, so I've got log of 15 over log of 3. And I go ahead and use my calculator and I solve it. So here is my answer for that one, my approximation. So now I want to write an equation, right? Because now I'm told to convert it to a log in base 2. So I know I've got log base 3 of 15 equals log base 2 of x. And again, I'm trying to find x. So I can go ahead and substitute log base 3 of 15 for that 2.4650, which I found above using the change of base formula. And then I can simplify by writing this log in exponential form, right? And so my base, which is this base 2, is my base here. The stuff that's on the other side becomes my exponent. And this x right here becomes what I'm solving for, right? So this is just converting between log and exponential form. So then this is something I go and put in my calculator, 2 to the 2.46 da 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 da, and I can continue that on and use my calculator. So this expression, log base 3 of 15, is approximately equal to the 2.4650, or log base 2 of 5.5212. So we have to first use the change of base formula. Then we simplify, then we go from logarithmic to exponential form. We change forms here, and then we can still use our calculator to get there. So let's look at another example. Okay, so now we're going to be looking at some logarithmic equations. So I'm told I need to solve log of 3x plus 1 equals 5. So the first thing I want to do is I want to write this in exponential form, right? So I take my base, which is 10, to the 5th, because it's this thing over here, equals whatever's left. So now this is something I've seen before, right? This is something I can just put this in my calculator, or I know that I have to add 5 zeros. I have to have 5 zeros here, and then just simplify for x. Okay. The second way I can solve this logarithmic equation is by graphing. So I can graph my equation in my graphing calculator of log 3x plus 1 and y sub 2, so this is just my second graph, equals 5, right? And I get that 5 from what it's equaling over here. So I can find my min and max using my calculator, and then I can find the point of intersection. So if you want to sit down with me and figure out how your calculator actually does this without you having to do all the work, come in and see me, because there's some tips for this one. The third way that I can do this is I can use a table to solve these. Okay, so I go ahead and I get my 0 all by itself, so I get everything to one side, so I subtract 5 from both sides. That's how I get this little equation. So I've got log base 10 again of 3x plus 1 minus 5. So then I use my tables. This is probably the most difficult way to do it, so I would definitely recommend knowing this first method and maybe even the second method, but this third one we're really not going to use. So no matter which way I do it, I can always go back and check. I can put that value that I get for x back in and double check, and I get the same thing. So I know I'm right on track. So we're going to be using now the logarithmic properties to solve an equation. So I'm given this kind of big 2 log x minus log 3 equals 2. So the first thing I need to do is write this as a simple one single logarithm, right? So I see here I've got this 2 out front, and I don't like that out there, so I will need to turn this into an exponent. Then I see I'm subtracting, so I'm going to use my quotient property to get that. So now that I'm here, I can go ahead and write it, and now that I have one single logarithm, I can write this in exponential form. So my base 10 to this 2 power, so squared, equals what I have left over here, x squared divided by 3. So the first thing I do, right, is I multiply both sides by 3, and then I take the square root. And remember that when I take the square root of a value, I have to have this plus and minus, because it is both. It's positive and it's negative. But here's a little caveat. The log of x is defined only when x is greater than 0. So I really only have one solution here. So it's 10 times the square root of 3, or approximately 17.32. So the first thing I did was I wrote my logarithms as a single logarithm so that I could write it in exponential form and solve from there. So here's your homework for this lesson. A couple of workbook problems and then a couple of con skills that I want you to work on. So let's look back at our learning target for today. I can solve exponential and logarithmic equations by using the properties of logs and converting between the two forms. We also looked at using a graph to solve the equations, but we want to make sure that we can solve it if we don't have the graph available to us.